Good afternoon. Thank you for coming. My name is Cesar Cerrudo. I'm going to present Token Kidnapping's Revenge. This is kind of follow-up of research I did before that was called Token Kidnapping. All the issues I found in previous research were fixed, and these are all new issues. The objectives of this talk are first to demonstrate that while Windows operating systems are getting more secure with every new version, there are still some issues that are very easy to find. Just scratching the surface, you can find some issues. This allows to bypass protection, etc., as we are going to see. Another objective is try to show you how I found these issues with the tools, with the techniques I used, so you can learn, so you can do it at home or work. So it's an important thing for me as a takeaway for you, if you can learn something today. So I'm going to be fast. I have a lot of demonstrations. So in the past, think about Windows 2000 and before. All the Windows services used to run under the local system account, which is the most powerful account on Windows operating systems. So if a service was compromised, then all the system was compromised. Then, with Windows 2003 and XP, Microsoft introduced a couple of new user accounts called Network Service and Local Service. These accounts has restricted privileges. They have fewer privileges than the local system account. So in theory, they started to run some system services under this account to prevent when one of these services was exploited. That doesn't mean that all the system was going to be compromised. Then, with Windows Vista, Windows 2008, and Windows 7, there were a lot of new protections for Windows services. They improved a lot from the previous operating system version, but we are going to see that this protection can be easily bypassed by some issues, by exploiting some issues. Let's see some theory first about what is impersonation and what are tokens. So impersonation is, we can say, is when a thread can act as it's running under another user account as the process that's on the thread. I mean, for instance, we have a process that is running under the network service account, so that process can impersonate. So when a thread starts to impersonate, it can start acting as it were another user. So when this thread starts to access resources such as file system or registry, all the ACL checks are performed against the impersonated user and not the user that the process is running under. And there are many different APIs to impersonate. Here we have a few, like impersonate namepipe client, impersonate logged on user, and RPC impersonate client. So when you call one of these APIs and a client connect to your service, then if you can impersonate, you start impersonating. In order to be able to impersonate, the account that the process is running under has to have the impersonate a client after authentication privileges. This privilege is not assigned to all users, only to accounts such as network service, local service, and accounts used to run service on Windows. Also, IIS, Internet Information Services, worker processes, the processes that are used to run web application, those has impersonation privileges too. And also we have Windows Management Instrumentation processes, which also has impersonation, and they run under network service, local service, and local system account. So when a thread starts to impersonate, it will get impersonation, an associated impersonation token. Oh. Well, a token is a Windows object that has information about the security context of a thread or a process. It includes information such as the identity of the user and the privileges associated with the user. There are two kinds of tokens. We have primary tokens and impersonation tokens. The primary ones are those that are assigned to processes during process creation. And then the impersonation tokens are those that are get when a thread impersonates. And there are different levels of impersonation. We have security anonymous, identity impersonation, and delegation. We will focus on the impersonation level, which is when a thread can act like he's another user. On Windows XP and 2003, the services run under the network service, local system, or user account. And all the services on this Windows version can impersonate. There was a weakness I found in my previous research that if there were two service processes running under the same account, they could access each other and get a token, impersonation token from the other process and elevate privileges. So what Microsoft did was adding a protection to special processes and services to avoid them to access each other and get token and elevate privileges. So they protected mostly processes that impersonate the system account. So for instance, they protected the service that ran RPC. And they also protected Windows management instrumentation processes. We also impersonated the system account. On Windows Vista 2008 and Windows 7, one of the new protections that were added by Microsoft is called per service SID. This is a really good protection, but no. But basically what they do is just put a special ACL in the process object. So for instance, we have a service that is running on the network service account. So they remove the network service account from the ACL of the process, and they insert a unique SID on the ACL. This means that the other processes that are running under the network service account won't be able to access these processes because they don't have permissions. Basically, this is almost the same protection they added to fix the issues on Windows XP and 2003. I found a couple of weaknesses on Windows Vista and 2008 that while the regular thread were properly protected by an ACL, like the same as the process, the thread from thread pools, with our special kind of thread managed by pools on Windows, is a functionality provided to automatically manage thread. They had the default ACL. So other processes running on the same account could access these thread pools and manipulate them and elevate privileges or do other things from another process different than the process that was attacking. Another issue was, like, I think I already said that, Windows management instrumentation processes that runs on the network service, local service, and system account, they were not protected by a proper ACL. And these services, these processes impersonate the system account. So any other process running under the same account can access these processes and steal the token and elevate privileges. So the fix that Microsoft did was properly protect the thread from the thread pools with a proper ACL, and also the same for the Windows management instrumentation processes. So when I When Windows 7 was available, I think it was the release candidate, I decided to take a look at it to see if I could find some low-hanging fruit, just, like I said, scratching the surface to see if there was something easy to find with simple tools. I will show you the tools. For instance, we have Process Explorer tool. This tool allows you to run all the processes on a Windows system. You can see here the process names, the process IDs in this column, description of the process. Here you can see the username that the process is running under. You can see if DEP is enabled, the integrity level of the process, etc. And when you select one process, you can see information related to the process. Here we can see all the handles the process has opened. We can see the token handles, the thread handles, registry key handles, same for file handles, etc. Also, we can see the information related to the process, like the security. We can see the permissions, the ACL of the process, the privileges assigned to the account that the process is running under. We can see the thread. It's a lot of information. For instance, if you double-click over a service, in this case is SVC host process, which is a hosting process that is hosting many services inside. We can see here all the services. We can see the permissions. We can stop and start the services. This tool is really easy to use and very powerful. So I started to play with this tool, looking around permissions, processes, on the handles, etc. And I couldn't find anything in a couple of minutes. So I think I also checked if the protections Microsoft added to fix the issues I found before were okay, and everything was fine. So I thought that it was pretty secure. Then I remember that I have found a little issue on Windows 2008. But it's a minor issue. The issue is about on telephony service. We can see here, this is another SVC host process that is hosting 5 services, and one of them is the telephony service, TAPI service. The issue is that inside this process, there is a process handle from another process. You can see here the process ID is 1308. I don't know if you can see there. This one is process ID 976. And this service runs under the network service account. You can see it here, network service account. But the other process that this process has the handle inside, that process was, let me see, 976. We can go to process 976, and this process ran under the system account. So this is weird because there is a process running under a low privileges account, having a handle, a process handle for a privileged process. So I took a look at Windows Debugger to see what were the access of that handle. So we can attach the process on WinDebug and take a look at the handles. And you can see here the handle value in hexa notation. This is the handle from the process itself, and this is the handle from the process that is running under the system account. And we can see here that it has granted access, duplicate handle granted access. That means that from this process, I can access any handle from the other process, duplicate them, and do whatever I want. I can do almost anything with the other process, and this is clearly an issue because I am accessing from a process running on the network service account to a process running under the system account, which is the most powerful account on Windows. So I could duplicate, for instance, the primary token, which will be a system token, and use it to elevate privileges. It's pretty simple. But in order to exploit this issue, first you have to find an issue on the telephony service itself, because this will be a post-exploitation issue that I could use to elevate privileges. But first, I had to find an issue on the telephony service. So that was the only I was getting when looking at Windows 7, so I started to focus on the telephony service. So I decided to use there is another tool called Process Monitor. It allows you to monitor all system activity on the Windows operating system. And it allows you to filter by many options. You can filter by process ID to display activity to a specific process, by process name, by path of the object that is being accessed, etc. You have a lot of options. This is also a very powerful tool. And you can monitor at the same time registry access, file access, network access. So what I did was set a filter to monitor only the telephony service and run the tool. And after running the tool, I have to interact in some way to the service. So the service will perform some action that will be captured by the tool. So what I did was stopping and starting the service. And you can see there in the background the tool is capturing activity. So I stopped the service, then I started again, and a lot of activities was being captured. So when looking at the capture, there were a lot of things. So I started to look around, and there was something that got my attention. That was one registry key that I haven't seen before. It's a registry key on HKey local machine key, and the subkey is called tracing/TAPI SRB. I don't know if you can see it there. So I went to registry editor to look at this registry key, and I thought about checking permissions on the key. And when I checked the permission, I found a surprise there. I found that the local service, network service, and user's account had a special permission. So I went to see what were those special permissions, and I found out that all this account could set value, has the permission of set value in this registry key. So this is another issue, because any user can set any value in this registry key that is then read by a privileged process, such as the telephony service. So I think this was a way to maybe exploiting something and then elevate the privileges with the previous issue. So I started to look around at the registry values, also at the registry subkeys, and I could see you can see here very similar names to processes in Windows. So I thought it was a functionality that was used by many processes in Windows. I didn't know what it was about. I was just playing with the tools. So then I started to look at the values of the subkeys, and I found one interesting value called file directory that has a data value of directory, Windows directory. So I look at the directory and it was empty. You can see there is nothing there. Then I continue looking at the values, and I found another more interesting value that was almost self-describing. The values named enable file tracing. And it was a tracing, remember, tracing subkey. So I said, okay, let's set this value to 1 to see what happened. So I set the value to 1, and in the background, process monitor was still running. So I set the value to 1 and returned to see on process monitor if something was happening. And I couldn't find something interesting. Here at the end you can see a file being created in the directory that was specified in the registry. So when I saw this, I started to think that it was exploitable. Maybe the guys that know about Windows local exploitation know how to exploit it already. So I could get a file created in any directory I want. So it was clearly an issue because any user could do that, could change that registry key. You can see there the file that was created, is tapi srb log. So after this, I started to research more what was this tracing functionality. I noticed that it was a functionality used by some services and processes to save information related with the bug, with errors. I don't know, maybe Microsoft used this information for customer support, I don't know. But basically, in that file that is created is basically saved the bug information and error information. So the way to exploit it is pretty simple. NamePipe, you remember one of the APIs used for impersonation I mentioned at the beginning is called Impersonate NamePipe client. What you can do is build a simple program that creates a NamePipe, listen on the pipe and wait for connections. When it gets a connection, it will impersonate the process that is connecting to the pipe. So I saw the issue was very easy to exploit, but I have to confirm if the process will try to access the pipe. So I set in the file directory value / localhost / pipe / x, which will be a name pipe. And after setting the value, I went to process monitor and I found that the telephony service was trying to access the name pipe. You can see there, it is trying to access the name pipe. So this was clearly exploitable and pretty easy to exploit. Just the only need for an attacker to exploit this is to be able to impersonate. If you can impersonate, then you can elevate first privileges to network service account, which is the TAPI service account, and from the TAPI service account you can access the other process that is running under the system account, because the process is handled with duplicate handle privileges. So basically you can go from any user with impersonation privileges to local system account. But changing the registry value for the telephony service will be a two-stage attack. So I decided to look at the other registry keys, and I found one familiar for me, which is IPH LPSBC, which reminded me to the IP helper service. So I went to Process Explorer trying to see if there was the same name as the IP helper. So I looked for the IP helper and I found it. You can see there the IP helper service is hosted in a SVC host process, and the process runs under the system account. So this is the best candidate for exploitation. I only need to write a value to the subkey of this service, putting a name pipe there, and they wait for the connection of this service and impersonate the system account and elevate privileges. You can see there I changed the value, enable file tracing, and then on process monitor, you can see here the file is being created after I changed the value when I enabled the tracing functionality. when doing a more in-depth research, I started to debug a little, and I found out that the processes that use this tracing functionality, they will be monitoring all the time for the registry. So if there is any change to the registry key, they will read it instantly. There is a special API used to monitor changes on registry, and they use it. So the exploit is pretty simple. What you have to do is just set a name pipe, create it, listen on it, change the registry value to the name pipe, enable file tracing, and you get the impersonation token from the system account and elevate privileges. I will show you an exploit now. I run netcat locally, and then I have accessing an Internet Information Service 7.5, which I have a .NET command shell there. I can run any command, and you can see the version is 6.1, is Windows 2008 release 2, and you can see the web application, the worker process of Internet Information Services is running under this special account called Default App Pool that was introduced on Windows 2000 release 2. Microsoft decided to change that the services, the web application on Internet Information Services don't run anymore by default under the network service account. So now by default they run under this special account, which has the same privileges as the network service account. It can impersonate, which is cool. So I uploaded this command shell to the server. Then I also uploaded the exploit. The exploit is called Chimichurri. So I put the path of deploy, the remote IP, and the port number. I run the exploit, and I get a reverse shell on my host, and you can see here is a reverse shell running under the system account. So it's pretty easy to exploit. You just need to be able to upload some stuff to some Internet Information Server, and you can root the system. Let's see some code. Well, this exploit is called Chimichurri, which is an Argentinian sauce used for churrasco. It was an idea of Federico Kirschman, San Federico, for the nice name. So basically, this exploit, what it does is creating the pipe. You can see here the name of the pipe with the file name that is created by the service when tracing functionality is enabled. So we set this value on the registry value, and then enable file tracing, and we get this file, the name pipe, try to be accessed. So here the name pipe is created. Here we can listen on the pipe, and when we get the connection, we impersonate, and with the impersonation we open the thread token and we run a reverse shell. The trigger of the vulnerability is here. This is the trigger of the vulnerability. So we set the tracing file tracing name to this value, and then we enable file tracing, and that's it. It's a pretty simple exploit. So after finding this issue, I decided to continue looking at the telephony service, because it was very easy to find these issues, and I saw there will be more easy to find. So I found that with the dialer application, which you can dial and call by using the modem, you can interact with the telephony service. It uses the service to make the telephone connection, to handle the modem, etc. So I run the dialer application while monitoring the activity with Process Monitor, and a lot of activity was captured. So looking at the capture, I found another interesting key, registry key, which I haven't seen before. So it got my attention. It's on HKey, local machine, software, Microsoft, Windows, current version, telephony. So I went to this to see what was this registry about with registry editor, and again, the first thing I did was checking the permissions, and I found another issue there when checking the permissions. You can see there that network service account has full control over the key. Why this is an issue? Because you may think it is okay because the process running under the network account, so the process should have permission to manipulate this key. But the issue is that this breaks the per server, per SID protection, because any other service or process running under this account will be able to manipulate this registry key, which then will be read by the telephony service, which is a different service. So we are, by this permission issue, we are breaking the per service SID protection. But in order to exploit this, I had to find some way to do it. So I started to look at the different subkeys, and there were a lot of subkeys, until I found an interesting subkey with some interesting values. You can see there, provided file name 0, provided file name 1, provide many string values there that has a data value, what it seems to be a file name with extension TSP. Looking at the process monitor, I found that the service was trying to access these files. And to my surprise, these files were loaded as a DLL. You can see there that these files are loaded as DLL, load image operation. So the issue started to become very easy to exploit. So any service could change this registry value. Any process running under the network account could change this value and get a DLL loaded inside the telephony service. So I had to check if it was really a DLL. So what I did was open it with Notepad and check for the headers. You can see MF at the beginning, and this program cannot run in DOS mode, so it's actually a real DLL. So it was easy to exploit. I mean, just changing a registry value, but I had to find out how to interact with telephony service so it will load my DLL, because I could change the registry value, but that doesn't mean that the service will load it, because in this case, these files were loaded as DLL because the dialer application was interacting with the service, You can see there also the other file names are also loaded as DLLs. So what I did was going to MSDN, looking for information about the telephony service, to find out how I could, from my exploit, I could interact with the service to get the DLL loaded. So I started to look around the documentation until I found a really interesting API that was almost self-describing. The API is named Line Add Provider. And you can see in the description, this function install a new telephony service provider into the telephony system. And it has the first argument name is LPSF provider file name. So that got my attention because this argument name is almost as similar as the registry value name. And you can see the description is pointer to a non-terminated string containing the path of the service provided to be added. So I thought I had to try this API to see what happens. So I built a very simple application. It's a very simple application that we call the API line provider, and we pass as a first parameter toto.tsp. So I built this application and I started to run tests to see what will happen when I run it, what will do the telephony service with that. So first I ran it under the administrator account to see just if it worked or not. So I ran it, and on Process Monitor I could see that the telephony service was trying to find the file on all the registry path of the system. It couldn't find it because it didn't exist, but I could find out that this API really worked, and it will get me the DLL directory loaded. I had to confirm it with running under the network service and account. So what I did was I created a Windows task, set the task to run under the network service account. So I ran the task while monitoring with Process Monitor, and after running it, I could see the capture, and again the telephony service was trying to load the file. You can see here again, it tried to find the file on all the registered system path. So I could find out finally that it was an issue and was very easy to exploit. Just call the API, pass a DLL, and you get it loaded inside the telephony service. And from there, the DLL code can manipulate the handler of the process running under system account and elevate to system. So one last try I have to do was try to run the program as a local service account, because it was clearly that network service account will work because the registry permission was full control for network service account, but I had to try with local service account just in case. So I tried with the local service account, and I found out that also the telephony service tried to load the DLL. So the exploit, the risk was wider because in this case any user running under the network service or any process running under network service or local service account could get a DLL loaded inside the TAPI service and elevate privileges. Well, when running the dialer application and the test program, I noticed something. If you remember, in order to elevate privileges from the telephony service to local system account, we need to have the process handled with duplicate privileges inside the TAPI service. And in the test I did, sometimes that process handler wasn't there. And that was the case. Sometimes the exploit wouldn't work because I would be trapped inside that service without elevating privileges. So I have to find out why sometimes the process handler was there or not. So when running the dialer application, I noticed that also the telephony service get a handle of the dialer process. So I looked again with the Windows debugger, and I could find out that the dialer process handler has duplicate handle too. So I realized that any process that uses telephony service functionality will get a process handle with duplicate handle access inside the telephony service. So what I have to do now is to find out what was the service that was running under the system account and accessing the functionality of the telephony service. So I get PID of the process, and I started to look. It was a SBC. You can see here. It was a SBC host process, hosting a lot of services. So the option will be stop and start the service to see when the handle appears and disappears, and identify the service. By looking around at the different services, I found one that was really suspicious to be the guilty, because the name was Remote Access Connection Manager. So I said, okay, access, remote connection, it should use maybe telephony service functionality. So I stopped the service, and I went to look to the telephony service to see if the process handle was still there, and the process handle wasn't there. You can see there is only the process handle from the same process, not from the process running under the system account. So I found out what was the service that was running on the system account that was interacting with the telephony service. The next step was to check if any user could run this service, because if the service wasn't running, if I want to exploit the telephony service, I won't be able to get this process handle duplicated. So what I did was checking the permissions on the service, on the Raspman service, and I found out that any user can run the Raspman service. So if the service is not running, then you can run it and then exploit and elevate privileges. You will always have the handle inside the telephony service. I checked also, it was, my initial test was on Windows 7, but I did the same test on Windows 2008, release 1 and 2, and it was the same issues were there. I had to check also on Windows XP and 2003. To my surprise, the telephony service, the registry permission issues wasn't present on Windows 2003, so there were no issues related with the permissions. But the surprise was that the telephony service on Windows 2003 and Windows XP runs under the system account. So if I'm local system account or network service account, I just call the API and get the DLL running under the system account. It's more easy to exploit on Windows 2003 and XP. You can see here the telephony service running under the system account on Windows 2003. You can see that the permissions are okay on 2003, so no issues with registry permissions. So while I was researching the issues, I noticed something strange on registry access. Some processes trying to access some different subkeys with similar name under different keys also. So I started to look around. I have few time. I started to test again the fix for Windows Management Instrumentation process on Windows 2003, because what Microsoft did was protecting with a proper ACL these processes, because they impersonate the system account. You can see here and the process in charge of running this Windows Management Instrumentation process is the Deacon launch process. So I started to monitor this process, the Deacon launch process, and launched the Windows Management Instrumentation process with a test script. And you can see here that the Windows Management Instrumentation is running under the network service account, but if you look at the ACL of the process, the network service account isn't there. So this is the protection that was added by Microsoft. So I cannot access this process from another process running under the network service account. So I tried to find a way to modify this ACL to be able to exploit it. So I continued researching this, by looking at the process. In this case, is this SVC host process, which is the DCOM launcher process, is in charge of launching the Windows management instrumentation process, which are these. So I was monitoring the activity related with DCOM launch, and I found it accesses a lot of registry key. And I found something interesting. You can see here HKey user S1520 classes. This is the classes sub key for the network service account. The S1520 SID is the SID of the network service account, and this is the user key from that user account. So first, this process tried to access this key, and it successfully accessed it. But after accessing the subkey, it tried to access another subkey inside the previous one, and it's not found. So it's not found, so the process continued with activity, and later it tried to access the same subkey as before, but in another different key. In this case, the key is HKey classes root. So it tried to access the key in that, the subkey in that key, and it find it. And then after finding it, it will read the values, start to use these values. So I found that this was probably an issue, because the subkey under HKey user, this subkey can be manipulated by the user that the subkey belongs to. You can see there network service has full control over the subkey. But the key name HKey classes root can only be modified by administrators and system account, and cannot be modified by other users. So there is probably an issue here, because users can modify the user's subkey, and this subkey will be read by a privileged process. So this could be an exploitable issue. So I continue looking at the different values from the registry key that were that were being read. Windows problems. As you can see, Windows Media Player sometimes has some problems. Yeah. Okay, we'll continue with this. So there was the problem here was that we have two different keys, one controlled by administrators and one controlled by users. And these two different keys are accessed by a privileged process and try to read value from them. So I thought, what about if I create those values that are not present there? Maybe the process will read the values I create and use them, and maybe I can elevate privileges and modify the actions or do something. So I started to make some tests, creating the values that were not existing on the network service user subkey. So I created the value, started to change some options, and I couldn't get anything working at the first try. But then I found an interesting value called app ID flags. So I went to look for the value description on MSDN. I found it, and I said that it controls the behavior, the security behavior of COM servers. So I say, okay, and the value that was being used was number 2, that was secure COM server. So I say, maybe this value is used to secure the process. So let's try to set the value to 0. So I did that, create the value, set it to 0, run the test program, and I got the Windows management instrumentation process running without protection. So finally, I could find what was the Microsoft protection, was adding a new value to the registry to get the process protected. And because the issue of this service running under system code accessing two different keys and one user controllable, so I could set my own values and have the Windows management instrumentation process running without protections. And exploiting it will be easy because I already have the exploit that I did for my previous research. So the only change I have to do to the exploit was creating a registry value. The former exploit was Churrasco. This is Churrasquito, which is a small Churrasco. The only modification I had to do was just create the registry subkey and values. You can see here. So I create the subkey. Here you can see S1, 5 classes, app ID, and then set the app ID flags value to 0. So when I set this value to 0, then I call Windows Management Instrumentation functionality, get the process running unprotected, access the process, and get the system token from there and elevate privileges. This exploit is, like I said, almost the same as before and works on Internet Information Service 6. By default, it runs under the network service account. So you only need to upload a command shell or an ASP.NET exploit and run it, and you can compromise the Internet Information Server 6. So sadly, I don't know, let me show. Let me show the exploit video. It's pretty simple. It's almost this. No. So I run netcat locally. So I already uploaded a command shell. This is IIS 6. So I can run any command there. And you can see that by default, it runs under the network service account. This is Windows 2003, fully patched, and IIS is, this application is running on the network service account. So I run Churrasquito, set the remote IP and port number, and I get the remote shell running under the system account. Like I said, it's almost the same exploit, Churrasco, with a little modification, just creating a registry value, and that's it to bypass the fix that Microsoft introduces for my previous research. So we should be ending. So the threat scenarios basically are web hosting companies where they allow you to upload your stuff and you can run web applications, so you can compromise them for $5 or $4.99. In-company developers can also upload codes for testing, production. They are not administrators, but they can upload code, so they could also compromise servers. SQL Server administrators which are not Windows administration, they can also run programs, and SQL Server account can impersonate, so they can also compromise the server. And finally, like we already saw, on process protection scenarios, some of these issues will allow you to bypass the protection. Because first, you can exploit some service, and you will be kind of trapped there because you don't have enough privileges, and you cannot access other processes. By exploiting the issue, you will be able to elevate to system and escape from the protections. So about fixes, Microsoft will be fixing the registry key issue and another local elevation of privileges that I didn't speak about today, because any user can elevate privileges on Windows 2008, Vista and 7. Also, Microsoft is releasing an advisory stating the issues related with impersonation with the network service and local service account. So our final conclusion is that Microsoft has improved a lot, but some protection can be easily bypassed sometimes with simple issues like the one I showed. Like you saw, finding these issues are not difficult, just click around using public available tools. You just need where to look and observe and find the issues. So we are out of time. Thank you for coming. We have questions in the question and answer room if you want.